With our P3 class, we're going to be finishing the problems from Unit 1, Part 4. All right, this is about the normal model. So we know that these are normal. They told us to assume normality here. An electronic product takes an average of 3.4 hours to move through an assembly line. So this is my mu. If the standard deviation, so that's sigma, is 0.5 hours, what is the probability that an item will take between 3 and 4 hours? So what I'm going to do is use my z-score formula. But now, remember how the last time we did this, we just did Unit 1, Part 3, the last few problems? Remember how we did y minus y bar? They're telling us that this is a normal model. So now I'm going to use mu and sigma. All right, so let's do it for the first one. 3 minus 3.4 over 0.5. And the other one is 4 minus 3.4 over 0.5. Let's get those two z-scores. So 3 minus 3.4 divided by 0.5, which is negative 0.8. And then 4 minus 3.4 divided by 0.5, which is 1.2. All right, and you guys remember what they're asking here? If I draw my curve, try again. So you put down the z-scores. Negative 0.8 is about here. 1.2 a little farther to the right. And how do I shade? How am I going to shade on this normal model? Is there a key word in the question that'll tell you? Anyone? It's between. I'm sorry. It says between. So I'm going to be shading between. So to find my answer to this, I need to use my calculator. All right, so this is going to be second vars. And the button I'm going to use for this one is normal CDF. So number 2. What is my lower bound? Negative 0.8. And my upper bound is 1.2, which will give me an area of 0.673. So 0.673. So look at your answers. Letter E. Now, obviously, we didn't do 1, 2, and 3 in class right now. I did that earlier today. But in 1, 2, and 3, we had, I can show you the work. We had one where we shaded to the right, one where we shaded to the left. So we've already done, I know you haven't, but that's why this one is in between. We've already done shading in both directions. Okay, let's do number 5. It says the mean score on a college placement exam is 500 with a standard deviation of 100. 95% of the test takers score above what value? So I kind of just drew like a mini curve. All right. What's right down the middle? 500, right? And you can do the standard deviation of 3 to the right and 3 to the left. But really, the way I'm reading this is it says 95% of the test takers score above what number? So what I did was I put some value here, right? I don't know what it is, some score. And if I shade to the right, right above it, see how it's in blue? What does this area in blue need to be according to this problem? I try my best to make that like most of the curve, right? If you look in the problem, it says 95% of the test takers are scoring above this score. So this blue area should be 0.95. Now, the way we do this in our calculator is I cannot actually type in area to the right. I have to always type in area to the left. So if 95% of the test takers are to the right of it, how many are scoring below this number? Or I should say, what percentage are scoring below this number, 5%. So I'm going to be typing in 0.05. All right, and where you go to type that in is you go to inverse norm. So second vars number 3 for inverse norm. Type in 0.05. This is the area to the left of that number. Go ahead. Second vars. And then inverse norm, I think it's number 3. And type in 0.05. If you type in 0.95, that's okay, Carolina. Just got to make sure that that's going to give you a positive 1.645, and we actually want it to be negative. Okay, so go ahead and put down your formula. So z equals y minus mu over sigma. We know the z-score. We don't know the data value. That y, you guys know I like to use y, you can use x. All right, we don't know y, we're trying to find it. Minus the mean of 500 over the standard deviation of 100. So now it becomes an algebra problem. Can you isolate for y? All right, so what algebraic move should I do? Multiply by 100. So times 100. And then what's the last step? Add 500. So this is the score that 95% of our test takers are scoring above. So 335.5. And they rounded it to 336. Thomas.
Did you get 1.645 just from like it being 95%?
Yeah, so when I typed into the calculator, right, I did the inverse norm of 5%. So that means I'm telling the calculator, okay, can you tell me the z-score that has 5% of the data values to the left of it? And that would be this z-score, which shouldn't really surprise you because if you remember when we did confidence intervals, do you remember our z-star for a 95% confidence interval? Yeah, do you remember what it was? 95, 96, right? 1.96.
Yes.
So if you go back to like those days, right? This is 5% and this is 5%. What would be my confidence interval? 90. And what's the z-star for 90%? 645. So it's all connected to the normal model. I know, good times. All right, let's do 6. No. Yeah, T-star is, you have to, it depends on the degrees of freedom. Yeah. So you got to constantly find new T-stars. Z-stars you can memorize because they will always be the same. Okay, we have a mean, a standard deviation for income per household, the middle 95%. All right, so if I were to shade the middle 95%. Oh, very good. Let me try again. All right, so here we go. The middle 95%. Okay. How much is to the left and to the right?
2.5%.
Very good. So 0.025. So I'm going to do the same thing. Go to second vars inverse norm. So second vars inverse norm, which is number 3. And I'm going to type in 0.025. This is going to give me my z-score on the low side. So negative 1.96. Hopefully you're not that shocked by that, considering that middle 95%, right? What we just talked about, Joseph. And there's the positive version of it. So I do need to do 2 different formulas here, though, because I need to find 2 numbers. So I have negative 1.96 equals, I don't know, minus 9,500 over 1,750. And do the same thing but with a positive 1.96. All right, so let's get the first one. So times 1,750 plus 9,500. So $6,070. Does that give me enough for an answer now? Yep, it's B. I'll do the same thing for this one. 1.96 times 1750 plus 9,500, which is 12,930. Guys, this is all kind of variations on the same idea, all right? And just got to be ready on the AP exam to deal with the normal model. It's been a long time since we've done this, right? This is September, so just got to get your brain working with this again, all right? You guys did this, like I feel confident in it, you just got to try again, okay? All right, last one, then we'll be done. Cucumbers grown on a certain farm have weights with a standard deviation of 2 ounces. So this is sigma. What is the mean weight if 85% of the cucumbers weigh less than 16 ounces? All right, so we're trying to find mu, right? The question mark is mu. Let's draw the curve. All right. So again, I'm trying to find mu. I don't know what mu is. But it says 85% of the cucumbers weigh less than 16. So I'm going to put 16 over here. I don't really know where it goes, but I put it here because what amount of the curve has to be left of 16? What percentage of the curve that needs to be shaded to the left of it? Percentage? To the left of it. 85%, right? Because they got to weigh less than 16. So if I were to shade to the left, right, this is going to be 0.85. Okay? So I'm going to use inverse norm to give me a z-score associated with 16, and then use my formula to solve for the mean, because I don't know that. So do inverse norm. So second vars. Number 3. I'm going to put 0.85. That's to the left. So my z-score is 1.036. All right, so do my formula. Plug in what we know. We know the z-score. We know y is 16. What am I solving for? Mu, right? I don't know the mean. And sigma is 2. So the algebra is just different. So I'm going to move that 2 over with multiplication. So times 2. All right, I'm going to subtract 16. But remember, this is going to give me a negative. Is my mean negative? No, I can't have a negative weight. So I'm going to put positive 13.93 ounces. So A.